The wind load on the north side is significant.
We need to adjust the rebar structure here.
Capacity, span, and crowd flow needs are outlined. The structure must cover a vast area without internal columns. Engineering goals are set early.
The structural framework provides the enclosure,
and the redundancy ensures stability during the build phase.
The stadium is planned as a continuous outer shell. Loads are spread across many intersecting steel members. No single element dominates.
The structure is designed with ground movement in mind. Flexibility is introduced through geometry. Stability and adaptability work together. Advanced digital models map every steel member. Connections are defined before fabrication begins. Precision replaces guesswork.
The lattice appears irregular but follows strict rules. Angles and spacing are carefully calculated. Chaos is only visual.
Engineers trace how forces travel through the lattice. Multiple paths ensure balance. The structure shares responsibility.
Large roof spans are divided across the lattice network. Weight is distributed outward and downward. Interior space remains open. Steel is chosen for strength and adaptability. Section sizes vary based on position. Material efficiency is prioritized.
Complex joint nodes are developed digitally. Each node connects multiple steel members. Accuracy here defines success later.
Steel components are designed for off-site fabrication. Transport size and assembly sequence are considered. Construction efficiency is planned early.
The lattice is designed so no single member is critical. If one path weakens, others support the load. Resilience is built in.
The roof and facade are treated as one system. There is no clear separation between them. The stadium becomes a single structure.
Inside the shell, the seating bowl layout is defined. Sightlines and crowd circulation guide geometry. Structure supports experience.
Vertical and horizontal clearances are reviewed. The lattice must never interfere with movement. Spatial accuracy matters. Airflow around the open lattice is observed in models. The porous structure reduces pressure buildup. The form supports comfort. Rainwater paths are integrated into the structure. Water flows away naturally through the lattice. Maintenance is simplified. The overall shape is approved. Member positions are fixed digitally. No major changes follow this point.
Engineers plan the order of assembly. Temporary supports are identified. Every lift is anticipated.
The ground is cleared and leveled. Reference points are marked across the site. The project moves from screen to reality. Areas for structural supports are defined.
Fabrication drawings are finalized. Workshops prepare for steel production. The next phase approaches.
All right, bring it down slow. Easy now. Hold it right there, a little to the left. All right, set it down. Watch your hands.
Foundation grids are marked across the site. Reference points define structural alignment. Accuracy begins at ground level.
This section meets the depth requirement. Ensure the rebar alignment is checked before the pour.
Foundation beds are leveled and compacted. Surfaces appear uniform and stable. The ground is made ready to receive structure. Steel reinforcement is arranged within foundation zones. Spacing follows planned geometry. Support systems take shape.
Foundations remain undisturbed as concrete sets. Time is allowed for stability. Patience supports strength.
Completed foundations are inspected visually. Levels and positions align as planned. The site is ready to build upward.
In fabrication workshops, steel members are produced. Each piece follows precise digital specifications.
These curves must match the lattice geometry exactly.
Confirmed. The form must follow the calculation precisely.
Complex joint nodes are assembled in controlled conditions. Multiple connection points converge here. Precision is critical. Fabricated components are checked for accuracy. Dimensions and finishes are confirmed. Errors are corrected early. Steel members receive protective treatments. Surfaces are prepared for long-term exposure. Durability is addressed before assembly. Each steel element is labeled for sequence clarity. Assembly order becomes visible. Logistics simplifies construction. Steel members are arranged by type and size. Clear zones support safe lifting. Organization guides progress.
Temporary supports are installed at key points. They hold early steel elements in position. Stability is ensured during assembly.
Bring it down slow. Easy now. It's touching down on the left side. All right, secure it.
Intersecting steel members form the first visible lattice. Connections lock geometry in place. The bird's nest identity emerges.
Okay, easy down. Watch that guide pin.
Coming in contact now, looks good.
All right, hold it steady. Secured.
All right, bring it down slow. Watch that alignment. Rotate just a hair clockwise. Right there. Confirmed, looks good. All right, lower slowly. Hold it steady. Locked. Bring the next one up. Let's keep this rhythm going.
Alignment checks occur at each stage. The structure remains true to the model. Precision is continuous.
Supports are repositioned as the lattice grows. They adapt to new load paths. Construction remains flexible. The lattice gains three-dimensional presence. Overlapping layers create complexity. Strength builds through interconnection.
Inside the shell, groundwork begins for the seating bowl. Clear separation between shell and interior is maintained. Systems coexist without conflict.
All right, bring it up slow. Hold it right there. Locking in now. All right, bring it down slow. Watch the gap on your right. Hold it steady now.
Cross-referencing the specs now.
Looks good.
Yeah.
Confirmed. The geometry matches expectations.
Assembly speed increases as patterns repeat. Teams move with familiarity. Progress accelerates smoothly. Steel members continue to rise across the stadium perimeter. The outer shell grows denser and more connected. The structure gains visual depth.
Multiple layers of steel intersect at varying angles. The lattice thickens as planned. Strength emerges through overlap.
Engineers observe the growing lattice against reference points. Angles and spacing remain consistent. The pattern holds its logic. Steel elements defining the roof perimeter are installed. The boundary between wall and roof forms naturally. The shell remains continuous.
Long steel members bridge wide roof spans. Connections distribute forces across the lattice. Open interior space is preserved.
All right, easy down. She's set. Take the tension off. Looks perfect.
Engineers ensure steel density remains balanced. No area becomes overly concentrated. Uniformity supports stability.
Open areas within the roof structure are defined clearly. Light and air paths are preserved. The stadium remains breathable.
Hold it steady now! Raising the beam, clear the area below. Engineers review the shell as a continuous system. Load paths remain uninterrupted. The structure reads as one piece. Remaining gaps along the outer shell are filled. The lattice becomes visually complete. The bird's nest form is now unmistakable.
Hold it right there. All right, lowering slowly. Watch the connection point.
From a distance, the stadium silhouette is fully formed. The nest-like appearance becomes clear. Identity is established.
All right, hold it steady. Move it forward 2 feet. Holding steady. Moving forward.
The last major steel elements are lifted into place. Connections are secured methodically. The shell reaches completion.
Looks good up here. Connections are solid.
Agreed. The system feels resolved.
Temporary supports are fully withdrawn. The structure stands independently. Design intent is confirmed. Attention shifts toward roofing layers and cladding. The steel shell is ready to receive them. The next phase is prepared.
Structural assembly gives way to enclosure planning. The engineering backbone is complete. Focus begins to change.
The bird's nest steel lattice stands fully assembled. Its form is exact, balanced, and complete. The completed steel lattice stands still. Attention shifts from structure to enclosure. The next layer begins.
Roof layering sequences are reviewed on site. Each layer serves a specific function. Integration is carefully planned.
Secondary steel elements are installed within the lattice. They support roof systems without altering form. The shell remains dominant. Roof panels are positioned above interior spaces. They allow controlled daylight to enter. Light becomes part of design.
Protective layers are added above roof zones. Water is guided away from interior areas. Function remains discrete. Drainage paths are integrated into roof systems. Water movement remains hidden. Maintenance stays simple. Adjusting Sector 4 intensity now. Check the uniformity.
Looks perfect from here. Brightness is even and comfortable.
Construction shifts to the seating bowl framework. Concrete and steel form the interior skeleton. The spectator space takes shape. Precast components are installed efficiently. Each piece fits its assigned position. Consistency accelerates progress.
Stairs and walkways appear between seating sections. Movement routes remain intuitive. Crowd flow is planned early.
Concourse levels develop beneath the seating bowl. Open spaces allow smooth circulation. Structure supports scale. Entrances and exits align with concourse paths. Orientation remains clear. Navigation feels natural. Back-of-house areas are framed discreetly. Operations stay separated from public space. Function stays hidden.
Lighting systems are integrated within structure. Fixtures remain visually unobtrusive. Illumination supports events.
Interior surfaces are prepared to manage sound. Echo control is planned without altering structure. Comfort improves.
The central field area is leveled and shaped. Drainage and base layers are installed. The playing surface foundation is set.
The field system remains independent from the shell. Movement and vibration stay isolated. The relationship between roof height and seating is reviewed. Clear views are preserved. Proportions feel balanced.
Views from top seating tiers are observed. Sightlines remain uninterrupted. Design intent is confirmed.
Surfaces are prepared for final finishes. Materials remain neutral and durable. Focus stays on structure. Seats are installed row by row. Color and spacing follow the plan. The stadium feels complete. The final playing surface is laid. Texture and level appear uniform. The field is ready.
Bring it down easy now, easy. Yeah, hold it there, looks good. All right, set it.
Roof, seating, lighting, and circulation are reviewed together. All systems align. Nothing conflicts. Minor refinements are made quietly. No major changes are needed. Confidence remains steady.
Interior spaces relate clearly to the outer lattice.
Construction tools disappear from view. The stadium shifts toward use. The final phase begins. The bird's nest stands complete in form and function.
Structure, enclosure, and interior unite.
Operation is next.
The circulation paths certainly feel intuitive.
They do. Everything aligns as planned.
The roof system is observed under changing conditions.
Light and movement paths are tested without crowds. Entrances, exits, and concourses flow naturally. Orientation remains clear.
The playing surface is inspected closely. Level, texture, and drainage appear uniform. The field is ready for use.
Exterior lighting reveals the lattice at night. The steel form reads clearly against the sky. Identity remains strong.
With operations settling into a smooth routine, regular use across the venue quickly normalized. Movement during entry and exit remains steady. Paths support large volumes comfortably. Design intent is confirmed.
Between activities, the stadium returns to stillness. No systems demand attention. Passive design succeeds.
Access routes allow routine inspection. Movement within the lattice remains practical. Care is built in.
Days pass without visible change to form. Steel geometry remains exact. Consistency is evident.
Rain and wind move across the structure. The porous lattice responds naturally. Comfort and stability remain unchanged.
All right, bring it down slowly. Watch the far end, watch the clearance. Easy, easy. Set it down.
No adjustments are required after use. The structure performs without intervention. Design proves resilient.
The bird's nest functions as part of the city. Its presence feels permanent. Engineering blends into daily life.
Repeated use shows no deviation in behavior. Original decisions continue to perform. Longevity is clear.
Beijing National Stadium stands finished and enduring. Structure, function, and identity align. The engineering story closes.